All right, let's talk about translating functions. All right, by translating functions, all I really mean is moving them. Oh, sorry. So by translating, I just mean move them. I can either move them up or down, or I can move them left to right. So we're going to have a graph, we're going to have a function, and then we're going to move them. All right, there's going to be some specific stuff, and I'll come back to this particular page and show you what it looks like on the function. But for right now, let's just use a couple of the most basic ones. The first one, let's use x squared. All right, if you punch in f of x equals x squared, and I think if you write f of x in here, it should be good. Yes. If the function is f of x equals x squared, look at that shape. It's a u. Now, if I put something in front of this, like a negative, all it does is flip it. So when I delete the negative, it's upwards. When I include the negative, it's downwards. So when I put a negative in front, it just flips it. All right, so let's see what else happens. What else can I do here? So if I don't square just x, if I do x minus 2, for example, and square it, look at that. You see how it moved it to the right? Let me highlight this really quickly and then delete it again. So what if it's just x squared? You see where the point on the bottom, we call that thing the vertex. You see how it's at 0, 0? Now, when I put in minus 2, it moves over. The point is at 2, 0. It moved to the right. Similarly, if I go back and I do plus 2, it moves it to the left. So when I'm putting numbers inside of the set of parentheses here, and then I'm squaring all of it, I'm moving it to the left or the right. All right, I'm going to write that down in a moment. But for right now, let me just move on and do something different. What if I add 1 to it? All right, so remember, my vertex is at 0, 0. But what if I, onto my function, add 1? My vertex goes up to 0, 1, so it moved up 1. Similarly, if I subtracted 1, my vertex dropped down to 0, negative 1. And so when I put numbers on the outside here, I'm moving them up or down. All right, so with that said, let me generalize what I just said. All right, let me put this down in some theory real quick. Okay, if you have some function, f of x. Now, there is a general format for this kind of function. This is called a quadratic because it has a 2 right here. So something squared. You're going to get this U shape whenever you graph a quadratic. It's called a parabola. But you'll have an x and then you'll subtract some letter or some number. We're going to call it h so I can give it to you nice and general. And then you're going to add some number to it. We're going to call it k. I don't want to call that h also. So basically, this is the general form. This is actually called vertex form for a quadratic. So of a quadratic. Get used to that word quadratic. That's why I'm trying to use it. This is the vertex form of a quadratic. Anything raised to the second power is a quadratic. This h moves it left to right, and the k moves it up or down. All right. Now, when I say move it, in both of these cases, I'm talking about the vertex. That's just the point at the minimum or the maximum. Okay. Now, let me add another little piece here. Let's use something out here. Let's use an a right there, because I already showed you that if that a is negative, then your parabola goes downwards. If that a is positive, or in other words, if it's a positive number, the parabola goes up. All right, so this is just a basic idea of translating functions. In this case, I'm translating quadratic functions. I'm going to do another one like this for just a basic idea of absolute value, but it'll be very, very, very similar. And then we'll do some practice in general. All right, this is just the introduction.